So in this video, let's see what is Git and why should we use Git. So without a further ado, let's get started. Let's say for instance, you are starting a startup and you have a team of 5 people. When you're thinking about designing and developing projects, how do you keep track of different versions of your code? How do you collaborate with other people? How do you make sure that if you make a change and that change doesn't work better, and that you have an easy way to go back to older versions of your code and make sure that you have access to those as well. And so all of this process falls under the hood of what's called version control. In a nutshell, version control system is a piece of software that helps developers to work together and maintains a complete history of their work. It keeps track of all the changes of the project files and allowing developers to work with their team on the source code, while saving them a lot of confusion that tends to happen when multiple people are editing the same files. And it maintains and records every minute change in the code. Out there are many number of different version control software that many people are using on a daily basis. But among all of them, there's a software called Git, which is a version control tool that we're going to be using in this video. So let's look at the history of a Git. As I said earlier, Git is a distributed version control and source code management system. It was initially designed and developed by Linus Torvalds, the same guy who created the Linux kernel. Now let's see why should we use Git. First and foremost, it's free and it's open source. Git is released under GPL's open source license and it is available freely across the internet. As it's an open source, you can download its source code and also perform changes according to your requirements. The next reason is it is fast and efficient. As most of the operations are performed locally, it gives a huge benefits in terms of speed. Git is a distributed version control system and it does not rely on the central server. The core part of Git is written in C, which avoids runtime overheads associated with the language. The next reason is implicit backup. The chances of losing data are very minor when there are already multiple copies of it. Data present on any client-side mirrors the repository. Hence, it can be used in the events of a crash or disk corruption. The next reason is its security. Git uses a cryptographic hash function called SHA-1 or SHA-1 to name and identify objects within its database. Every file and every Git commit is checksummed and retrieved by checksum at the time of checkout. So it is merely impossible to change file, date and commit message and any other data from the Git database. The next reason is easier branching. With Git, it is very simple to manage the branches. It takes only few seconds to create, delete and merge branches. In addition to this, Git is also very good at letting you test your code without losing your original copy. So if you have a working program and for some reasons you want to make some modifications to it in order to add a new features, but then you're worried that adding that new feature might break some features that's already existing within your program. Git is very good at letting you test your new changes and experiment with your code without losing track of that original program. And only if you're happy with the original code that you have, can you then merge your new changes in with the existing changes so that you never lose a working copy of your original program. You might have come across the term called GitHub. GitHub is just a website whose purpose in life is to store Git repositories on the internet. It's to give you and people all around the world across the Git repositories on the internet, such that you can look at repositories that other people have created and contributed to them or use them, and such that you can work on your own project, push them to GitHub, so that your collaborators or other people on the internet can also see and use them. So that's the high level overview of Git and GitHub. And now let's see how to create a GitHub account. So for that, open your favorite browser and type github.com and hit enter. Now it will take you to the official GitHub website. So here we are. Click sign up and enter any username you like. In my case, I'll be typing swordfish 39 for random reasons, and enter your email address, and enter your password, and that's it. You're almost done. Now click create account. Choose free plan and click continue, and if you wish to fill these fields, go ahead, but in my case I'll be skipping this. Now that's it. We're pretty much done. What we'll be doing here is, we'll now create a GitHub repository. And for your information, repository is just a fancy word for the place where we're going to keep track of all of your code and all of the changes to your code. Think of it as like central storage place. So in the upper right, click this plus icon and select new repository. And here we can create our new repository. In this case, I'm going to name the repository as demo, and for the moment ignore this all and click create repository. This will create a new repository for us that's stored on GitHub. As of now, it's not on my local computer yet, but we'll see how we can take this repository and download a copy of it. In order to use Git, you need to install it first. For that, open your terminal and type the following command: sudo space apt-get install git, and hit enter. Enter your password and hit enter. In my case, I've already installed it, so let me clear this up. In order to check your Git version, type the following command: git space -- version. So here we are. So after we install Git, one of the first command you should learn is git clone. Git clone command has just one sole purpose. What it does is, it takes a repository which is stored somewhere else, like on some server like GitHub, and what happens is, when you run git clone followed with the URL of that repository, that remote version of your code will be downloaded onto your computer, so that you have a copy of that repository on your computer. So let's see how to do this. Now let's revert back over to GitHub repository that we just created, and you'll notice that a URL here. This is the URL of this GitHub repository. Now let's copy this URL and open your terminal and type the following command: git clone, paste the URL that you copied and hit enter. Now it's cloning that repository. Wait for a few seconds and we're done. And it gave us some warning message like you appear to have cloned an empty repository, which is true because we just created an repository but we haven't created any files in that. So let's change our directory and get into demo directory. For that, type cd space demo and hit enter. Now we are in demo directory. Type ls and hit enter. It's giving empty. So now let's add some files into that repository or that directory. Okay, now let's add some code to the repository that we just created. So for that, type touch space, enter any file name you want. In my case, I'll be typing example.html and hit enter, and type ls, and as you can see that example.html has been created for us. So let me open this file in VS Code. And as the VS Code got opened, let me type some HTML code. I'm just creating a basic web page. And here and let me save this. And after that, the next thing we'll need to know is git add. And the git add command usually means we are going to take some files, whether it may be one or more files that we've changed, and tell git that these are files that we want to include in the next time we make a commit. That means the next time we save a version or a snapshot of the current repository. So when I type git add followed by the file name, what it will do is it will tell git to track that file, that this is a file that I want to track the next time that I save a copy of repository. So let's see how to do this. Type git add and enter your file name. In my case, it's example.html and hit enter. Nothing appears to have happened, but that's fine. We have now added example.html as a file that I want to track the next time I make a save. The next thing we'll need to know is git commit. Commit is nothing but it's just a fancy way of saying take a snapshot of the repository in the current moment and save it. And how this will work is git commit space -m, m for message, and in quotation marks some English message describing what it is that we have changed in this commit. This will be useful because as you begin working on a project that has hundreds of commits, later on you can refer back to the list of messages that you have written describing what happened in any successive change, so that we'll know where to look if you are trying to find a particular commit or particular change that you made to your code at any particular time. So let's see how to do this. Type git commit -m and type any messages in these quotation marks. I'll be typing this. Example.html and hit enter. And you'll notice that Git provides us some helpful information about what it is I just did. It's saying that one file has been changed. So now Git has kept track of the fact that in this commit I've added hello.html in this file. I mean example.html. The next command we'll need to know is git status. Git status command displays the status of working directory and the staging area. It lets you see which changes have been staged, which haven't, and which files aren't being tracked by Git. It simply tells you what's currently going on in your repository. That's pretty much it. So let's see how to do this. Go ahead and run git status and hit enter. So it effectively tells us the current status of the repository. Now we've successfully made these changes to a repository in our local computer. So the question here is, how do we send these changes back to GitHub? This is where git push comes in handy. The git push command is used to upload local repository content to a remote repository, in our case GitHub. Pushing is how you transfer commits from your local repository to a remote repo. So that is git push. Now let's see how to do this. Type git push and hit enter. And wait for some time. Now it's asking your username. Type your username. In my case it's swordfish39 and hit enter. Now it's asking for password. Type your password here and hit enter. And that's it. And now we have successfully pushed the changes to GitHub. So let's go back to our GitHub repo and refresh the page. And now you'll see the contents. Now we have an example.html that's located inside this repository. So that's git push. The next command we'll need to know is git pull. Git pull is sort of inverse to git push. What if someone else has been working on your repository, has made changes to it and pushed those to GitHub, and now you want to download the latest version of the repository? So let's see how to do this. So first, let me edit this code here. So let me add another line. This time Dr. Strange. And let me close this. And commit change. And as you can see that the content of my web page on GitHub shows Iron Man and Dr. Strange. But if I were to check my computer, I just have Iron Man. Why only Iron Man? Because that change has been made on GitHub. It hasn't yet been reflected in my version of the code that's stored on my computer. So now type git pull to say pull down any of those latest changes from GitHub and hit enter. Wait for a few seconds. And now we successfully pull down the change to change here. Yeah, to make sure, check the code on your local computer. And as you can see, we have Iron Man and Dr. Strange. So while pushing and pulling code, can you and other people that you're working with collaborate together and on repository and make sure that you're keeping track of all changes that you make? But what can go wrong here? What might happen and cause things to not seem as simple as they are? Well, what if I decide to make a change here by adding a new line like Black Panther or something? Yeah, fine. So I make that change in my local repo, and let me add and track that by adding git add. Let me pull this up. Git add example.html and git commit. And hit enter. So that now I've added the third line to the contents of my example.html file. But what if someone else on the internet who have access to my GitHub repo decided to edit it differently and decided to say Captain America H3 Captain America. And commit changes. Yep. Now the online version says Iron Man, Doctor Strange, Captain America. But in my local version of the code, it says Iron Man, Doctor Strange and Black Panther. And if I try now to pull this code from GitHub, it's not going to be as simple as it was last time of just updating the changes, because Git doesn't know which change I actually want. Here, I've added Black Panther. Online, that's different sentence. So, we're going to need some way to reconcile these two things. In this type of scenario, let me introduce a topic called merge conflicts. Git will try whenever it can to automatically take any changes that have been made and combine them together automatically for you without you needing to worry about what's going on. So in this case, when you try and run git pull, what happens is that there's some sort of conflict. The pull can't happen. And so what you'll see is a merge that says automatic merge failed. You need to fix the conflict and then commit the results. So what does that look like? Well, what will happen is that if you open up the file with conflict, you'll see something that looks a little bit like this. You'll see a file with a bunch of less than signs and then head, some lines and then equals, some more lines, and then this sort of random long sequence of numbers and letters. It might seem a little bit of jargon at the moment, but we'll break down what this actually means. So when you look at a file like this, which results whenever there is a merge conflict by Git, there are a couple of things to keep in mind. One is that anything between head and all the equal signs are your changes, the things that you did on your computer. Anything between these equal signs and the greater than signs here, these are remote changes, the changes from GitHub that you are trying to pull down that were somehow in conflict. That these two lines couldn't automatically merge together, and this long sequence of numbers and letters is the conflict commit. So what do you do in a situation like this? All you need to do is remove all of the lines you didn't want, remove all of those less than, equal than, greater than lines, and also remove whichever part of the code you didn't want, leaving only the version that you want to be merged together, and then get rid of the white spaces, and then you can commit the result. So let's see how it looks like. For your information, locally we have 3 different sentences and remotely we had 3 different sentences. But the third sense differed. So now if I try and run a git pull, let me open terminal and type git pull. Yeah. What you'll notice is we tried to auto merge example.html, but then there was a conflict. There was a merge conflict in example.html. The automatic merge failed. We need to fix these conflicts and commit the results. So if I take a look at example.html in my text editor, just a second. What you'll notice is you'll see this less than head and then this version, which is my version, Black Panther, and then this version down here, which is the version from online. Git doesn't know which one I want, so I need to pick, and I'll just say, you know what, let's use the version that I had. So I'll go ahead and get rid of all these entire lines. Let me delete and this one also, and save this. Before we end this here, there are a couple of comments that you need to know. The first one is git log. What it does is effectively just shows you a history of all of the commits that you made. The next one is git reset. So if you made some changes, realize that you messed up and you want to go back to the way things were before, you can run one of these commands. That's it for this video. If you like the video, give it a thumbs up and post your comments on this video. I'll catch you in the next video. Until then, peace out.
nothing to deny.